So today we are going to look about what is linear and non-linear logistic regression. Linear regression is, first we'll define what is it. Models, it shows a model's relationship between independent and dependent variable. Dependent variable we call it as y, and independent variable we call it as x. So in this linear regression is one of the statistical approaches used to model the relationship between the dependent and the independent variable. So what is variable? The variable predicts the continuous outcome using a straight line equation. We call it as y is equal to mx plus b, or we can call it as a plus bx, where b is the slope and x is the input, y is the output, and a is the intercept. It helps us to make the predictions by fitting a straight line. That is, we call it as regression line through a set of data points. So this is the linear regression example. It is a method used to find, already I told that it is used to give a relationship between the independent and dependent variable. So to understand how one variable affects the another variable, this method helps us to predict the future values also. So when you go for visualizing the overall trend in the data set, and the red line in the plot shows the predicted values based on the model, while the blue dots represents the actual data. So when I draw the straight line, so we have to know how many data points have been connected. So many of the data points are lying above the line and below the line. So we have to make that in a linear regression model, almost or most of the data have been covered in that line, right? For that only we go for least square method for making all the data samples to align on the regression line. So what, for example, we are going to take a example as an how to predict the house price. So what are the given data are given? We'll be giving the how much square feet of the house area should be. Let it be for 1,000 or 1,500, 2,000, 2,500, 3,000. This is a square feet of an house we are giving you. So that is the input, and the price what we are going to expect is why we call it as. So we want the price in terms of lakhs. So we set the price to be 50 lakhs, 65, 80, 95, 110 lakhs. So now we know the regression equation is equal to y is equal to mx plus c or a plus bx. So whatever may be the notations you are going to use as an input and our slope or intercept variables, you can use it. So in this case, for example, if I'm going to say that if your C value is 20 and the slope value is 0.03, and yeah, so my equation becomes y is equal to 20 plus 0.03 x. So we know what is x. So you can substitute any one of the x value and you can find out how much is your total price of that house is for this much of square feet. What will be the output in terms of money, in terms of rupees, in terms of lakhs, in terms of dollars, if you can predict it. So this is how we can find for whatever the input data I've given, based on your slope or based on your intercept values, I can able to find out what will be the output. I can make an expectation or I can predict the value of which will be the output. So here there are many methods to find out the slope value and intercept value. One of the most commonly used method is going to be your least square method. So next is going to be your how the plot can be mapped. So you can see that. So x is the data input and red line represents the regression line, which is called y is equal to mx plus b. So we can draw the plot. So in that plot, how many points are there? 1, 2, 3, 4, 5. So 5 inputs we have given, 5 dots have been traced on the particular line. The table shows the relationship between the area of the house and the price. The example to demonstrate the perfect relationship where the price increases with the area. So as the area increases, the price amount also increases. So this is a table chart we have given. For the corresponding table chart, we have reproduced a linear graph. The assumptions what we are going to make in a linear regression case, first one is linearity. It shows the relationship between the input and the output, whether they are in linear or not. Next factor is going to be independence. Observations are made on on the basis of how much of independent of each other is, whether the x is independent or how much both the variables are independent with each other. Next is homoscedasticity. Is nothing but it's the constant variance of the errors. So next is going to be a normality. Normality is nothing but the residuals. We call it as an errors or normally distributed. So how much error we get it. So based on that error, how much adjustments we are going to make that so that the point is lies on the regression line. So what are the advantages and the limitations we have? So advantages and limitations are, the advantages is nothing but simple and easy to implement. Interpretable coefficients. Works well with the linear separable data. Whereas the limitations are, assumes a linear relationship, sensitive to the outliers, and cannot handle the complex patterns. Only for the simple patterns I can make use of this linear regression. So I told that suppose if the data are not lying in the regression value or regression line or the linear line, if there is a much difference between one point to the other point, what we are going to do is we are going to use some metrics. We are going to use some metrics so that that metrics is going to adjust the values, or it is going to manipulate those values to lie on the regression line. So we call that is going to be an R square value. By adjusting the R square value, I can able to make the point to lie on the regression line, and also the distance is as minimum as possible. So this is how we go for linear regression process. So the so the overall summary when we talk about the linear regression says that this applications are is predicting the house prices based on the area, location, forecasting sales, demand, estimating the employee salary based on the experience and education, risk management and finance. This is about this linear regression, what we have to do with, what we have to, for what kind of application I can able to go for my linear application. So finally we come to a conclusion that for simple transforms, simple things, I can make use of this linear regressions. For very complex natures, I can go for next type of regressions called as logistic regression. So this is the top topic. The next topic is going to be your introduction to